This video is going to cover the basics of set notation. The first thing you have to understand about set notations is there are no repetitions. So writing something like that is incorrect. And if you either write it down on a paper test or enter that into MyMathLab or WebWorks, that is going to be counted wrong because that's not a set. So that's not correct, and you write stuff without repetitions. Now the order doesn't matter. So this is a perfectly correct answer for a set, as is this. So the order doesn't matter, but we cannot have any repetitions. So this video is going to cover union, intersection, and complement. So with union, so suppose we have two sets A and B. Then the union of A and B, and it'll be written with this union symbol, will be the set consisting of everything in either A or B. So you combine the two sets into one set. And remember, you can't have repetitions. Okay, so if I've got something like this, okay, and I want to do A union B for that one. What you can do is you can write down the first set or the smaller set first, as it is, and then add anything in the second set, but you just don't want it repeated. So I'm not going to add that 1 in here because it's already in there. All right, now 2 is not in here, so I'll write that down. Now 3 is already in here, so I'm not going to write it down, can't have repetitions, and then 6, and then 10. Now this is a perfectly correct answer, but you know, your professor might want you to write them in order, or the answer in the back of the book usually gives them in order. But this is correct, and this is the same thing as if I put them in order. Okay, so either one of those is correct. Okay, so the union, you put both of these together into one set, but you eliminate any repetitions. Okay. Now, what about intersection? The intersection of A and B, written like this, is the set consisting of elements that are in both A and B. So they have to be in both sets. Okay. So if I go back to this example that I had here, and I want to know what the intersection of A and B is. Again, you just have to go through one set. Okay, so I'm going to start at 1. 1 is in A and it's in B, and so I include it. Now I come to 3. It is also in B, so I include that. Then I come to 5. That's not in B, so I leave it out. I come to 7. It's not in B, so I leave it out. And I come to 11. It's not in B, so I leave it out. And then I'm done. because I don't have to go through B, because if there's any duplicates, anything in both of them, I've already written it down here. So, well, you didn't consider the 2. Well, I didn't have to because it wasn't in A. And for it to be in the intersection, it has to be in both. Okay, so we're only having the things that are in both. So as you can see, 1 is in both sets and 3 is in both sets. And there's not anything else that's in both sets. So that's the intersection. Okay. Now there's a special set called the null set or the empty set. And it's written either as a set that's empty or it has a symbol, a null set symbol. Okay. All right, so let's have a look at let's have a look at some of these. Let's look at B and E. So what about the union of B and E? Well, you kind of want to have it like that so you don't have any distractions there. I'm just going to take everything in B and then I'm going to add on everything in E, but I just make sure I don't have any duplicates. So I'm going to add on a 0 if it's not in here, and I'll add on a 5, and it's not in there. And this is correct. And then I might order it from smallest to largest. But if you were to enter this in my MathLab or WebWork, this should be a correct answer because the order doesn't matter. But if you were looking at it in a textbook, in the back of the book, you'd probably see it like that. So either way is correct. Okay. All right. Now, what about the intersection? And you can, I said before, you can start with the first one or the smallest one. Why don't we just start with the smallest one? And E is the smallest one, and I look at 0, it is not in both of them, and I look at 5, it is not in both of them. So there's not going to be anything in common with these two, and so their intersection is the null set. Okay, there's nothing in common. Okay. Now let me look at C and E. What is the intersection of C and E? Okay, so these two. And I'm going to start with the smaller one, and they both have a 0, but they both don't have a 5. Okay, so that's the intersection of C and E. Now, notice these are two different things. Okay, the null set is the empty set, and some students think that a set with just the element of 0 is an empty set. It's not. It actually has an element in there. The element is 0. Okay, so we just don't want to get that mixed up. Okay, now what if we have this type of thing? Okay, when you have something like that, then do what's in the parentheses first. Now, okay, so we're working with these sets. Okay, so we've already done this here. We've already done that. So this is going to be this set. and then in union with D, and I'll just write it down here. And you're just going to write one big set. So I've got 1, 3, and then I'm going to put these in here. Just remember, you cannot have repetitions. 0, 4, 9, 10, 11. Okay. And that finishes that. Now, what if I had something like that? Well, you do the parentheses first. And we've already done A union B. We've already done that. Okay, so I'll write that down here. And then I want to intersect that with D. And D is this one. So I only want things that are in both. And so you can start with the smaller set and then just check what's in both. Okay, so 0 is not in both. 4 is not in both. 9 is not in both. 10 is in both. And 11 is in both. And you pick one set and you go all the way through it and then you're done. So always pick the smaller set. And so this is what we get for this. Now, what does the complement mean? Well, to talk about complement, you have to have a universal set. Okay, so a universal set is, well, the way it sounds like, and it's usually denoted with a capital U. So this is the universe of elements that you're allowed to have. So these subsets, okay, which are smaller sets made up of elements in the universal set, all contain elements inside here. So we don't have, like, for instance, one of these having lowercase a, because it's not in the universe. Also, we don't have anything made up of the number 1 down here because it's not in our universe. This universe only consists of these elements. Okay, so if you want to do the complement, there's a lot of different ways that books have of writing this. So the textbook that I'm teaching out of right now, if I want the complement of A, the textbook that I'm using right now writes it like this. But other textbooks will write it with a bar over A. And other textbooks will have the complement denoted as the universal set and then this symbol. And you can kind of think of that as a subtraction symbol, because what it's going to be, so the complement of a set A, and we don't even have to have the specific one, so U is our universal set, is going to equal every entry in the universal set that is not in A. And you can think of it as, this is actually a good notation, because you can think of that as the universal set minus A. In other words, remove all elements of A from the universal set. Okay, so if we come back to this one, okay, So what is the complement of A? So I think WebWorks uses it like that. All of those are the complement of A. And you only include the stuff in the universal set that's not in A. So 0 is in the universal set, but it's not in A. So it will be in the complement of A. 2 is in A, so don't include that. I only want the stuff that's not in A. 4 is not in A. 6 is in A, so that's not included. X is in A, Y is in A. Z is not in A. So when you think of complement, think not A. That's what you should think of. Okay. All right. So what would something like what would that look like? Okay. Or that look like? Well, first you have to get this. Okay. So let's find out what the complement of B is. All right, so I want the stuff in the universal set that's not in B. So I can see 2 is not in B, 6 is not in B, X is not in B, and Y is not in B. Okay, so this is going to equal the complement of B, which I'll write here, intersected with C. Okay. And now with intersection, what's in both of those? Well, they have a 2 in common. Okay, no X, and they have a Y in common. So again, you can go through one of them. All right, they do have a 2 in common, not the 6, not the X, but they do have a Y in common. As soon as you go through one set, you're done. And so that's the answer to this one. So what if you have, I don't know, something like that. Well, again, you do the parentheses first. And if I was going to do the parentheses first, well, then I would have had to have done the complement of B first and then C. But I've already done this. Okay. So that's going to be and my A here is 2, 6, comma X, comma Y. And we can see they have a 2 in common and they do have a Y in common. And so we're done. All right. What if we do that? Well, you're going to have to get A union B first. Okay, and so that's going to be everything that's both of them put together into one set. So I just write the first one and then I go to the second one and you don't have any repetitions. So 0 and then 4 and then Z. And then if you like, you can write things in order. So with the numbers, I have 0 to 6. And with the 0 2, 4, 6, my bad. And with the letters, I have X, Y, Z. Okay. And now, what is the complement of A union B? Well, the complement of A union B is everything in the universal set that's not in A union B. Well, a 0's in there, 2 is in there, 4 is in there, 6 is in there, X is in there, Y is in there, Z is in there, and there's nothing that's not in A union B that's in the universal set. Okay. What if we had something like that? Okay. Well, I'd have to get not A and not B first, and we've done that. Okay, we've done that earlier in the video. And then not B is that. And so now I just take the intersection of these two. And I go through this one. No, 0's not in there. 4's not in both of them. Z's not in both of them. Okay. Now, what if you had that? Well, you have to get A intersect B first. And did we do A intersect B? I don't know if we have. Okay, well that's okay. And we can see there's nothing in common between these two. So what is the complement of the null set? Well, it's going to be everything in the universal set that's not in here. And so we actually get the universal set. So everything. So if they have nothing in common, then the complement of that is going to be that. Okay, any others that I can think of? Okay, well, you're going to have to do that one first. And I write these together. So 0, 4, Z. And then 2's not repeated. The 4 is repeated, so I don't write it again. Then a Y, and then the Z's already in here. And then you might want to put things in order. Okay. So that's that. Now, what about the complement of this? Well, it's going to be everything in the universal set that's not in here. So 0 is in there, 2 is in there, 4 is in there, but 6 is in the universal set, but it's not in here. X is in the universal set, but it's not in B union C, so it will be in the complement. And then that's all we get. All right, so I'm going to stop there.